today's problem from ordinary differential equation, and this problem is a linear ordinary differential equation which is non-homogeneous because the right side is not 0 and this is of constant coefficient. So we know that the solution or general solution of this type of equation have two parts. The first part is complementary function and second part is particular integration, okay, or it is known as particular solution, and this is the general solution. And we let the general solution, we know that this is y, and let complementary function is yc and particular integral is yp. Okay, so we have to find the value of yc and yp one by one from this equation. We first let, for this type of equation, we first let the trial solution of the homogeneous part is y, this is equal to c e to the power mx. Okay, and we know that auxiliary equation of, if we name this equation as 1, auxiliary equation of 1 is given by m square minus a square, this is equal to 0. So we get m, this is equal to plus minus a. Okay, so auxiliary equation have two real and unequal root. So clearly we write the complementary function which is yc is given by c1 e to the power ax plus c2 e to the power minus ax. Okay, now if we write this e to the power ax and this e to the power minus x using this formula, then we get that this is yc which is given by c1 into cos hyperbolic ax plus sin hyperbolic ax plus c2 into, this is also cos hyperbolic ax minus sin hyperbolic ax, and arranging this term we can write this is a into cos hyperbolic ax plus b into sin hyperbolic ax. We put here c1 plus c2, this is a, and c1 minus c2, this is b. Okay, and this is yc we get. Now to find the particular integration, this is yp which is given by, this is f of d into x. Here f of d, this means d square minus a square into x, x means p into sin hyperbolic ax. Okay, so we get this is p by 2 into 1 by d minus a into d plus a. We write sin hyperbolic x as sin hyperbolic x or ax, this means this formula. We already write here 2 and we write here e to the power ax minus e to the power minus ax. Okay, now this is p by 2 into 1 by d minus a into d plus a into e to the power ax, and the second part is 1 by d minus a into d plus a into e to the power minus x. It has two parts. Now we use the rule of finding particular integral if the x is exponential function. Okay, if we see that f of a not equal to 0, that is if we put in the factor in the denominator, if we put a in place of d, if f of a not equal to 0, then we directly put the value of a here in place of d and write the particular integral as this. And if f of a equal to 0, then we write e to the power ax in the left, but d becomes d plus a, and 1 can be written here as the operating factor or operating function. Okay, and clearly we get that if we put d equal to a here, then this factor is 0, but if we put here d equal to a, then this factor is not 0. So we put d equal to a here, but we put d equal to d plus a here, and we write in the left side of the factor. Okay, so we get e to the power ax into 1 by d plus a minus a into d, this is a plus a, because in this vector if we put d equal to a, then this is not given, and we write here 1. Okay, minus, in similar manner, if we put here d equal to minus a, because this is e to the power minus ax, then this factor is not 0, so we put minus a, and here we put d equal to d minus a, because here a equal to minus a. Okay, so we get d minus a plus a, and also here we write another 1. Okay, so we get p by 2 into e to the power ax by 2a, because this is 2a, and we get a cancel out, 1 by d into 1. And similarly we get from here, this is minus 2a, so we get plus 1 by 2a into 1 by d, because a cancel out, this is also 1. Okay, so here also we write e to the power minus ax. We forget to write this. E to the power minus x, also e to the power minus ax. Okay, now we take common 1 by 2a from both the vector, and 1 by d into 1, this means integration 1 dx. This is clearly x. Okay, so the final result is p by, this is 4a into, from here we get e to the power ax into x, plus from here we get also e to the power minus ax into x. Okay, so we can write this vector as px by 2a, and we get 1 2 is in here, this is e to the power ax plus e to the power minus ax by 2. Clear? And this can be written as, here we write this is px by 2a into, this is cos hyperbolic ax, because the formula of cos hyperbolic ax is this. Okay, so we get, this is y, this is yp. Okay, now here we write yc and yp to get the general solution, and the general solution becomes a cos hyperbolic ax plus b sin hyperbolic ax, plus this is given by px by 2a cos hyperbolic ax, and arranging in order we get a plus px by 2a into cos hyperbolic ax plus b into sin hyperbolic ax. Okay, and this is the general solution of the given differential equation. Very interesting differential equation from your exercise. Thank you for watching.